Hi, in this video, I will be showing you problem number 21 of chapter 12, section 6. Match the equation with its graph labeled 1 through 8. Give reasons for your choice. Number 21. X square plus 4y square plus 9z square equal to 1. Number 23. X square minus y square plus z square equal to 1. Number 25, y equal to 2x square plus z square. Number 27, x square plus 2z square equal to 1. Let's first consider number 21, which is x square plus 4y square plus 9z square equal to 1. So we can bring it to an ellipsoid form, which is x square over a square plus y square over b square plus z square over c square equal to 1. To do that, we can write this as x square over 1. 4 can be brought down and it's 1/4. 9 can be brought down and be written as 1 over 9 in the denominator. So it now takes up the form x square over a square plus y square over b square plus z square over c square equal to 1, which is nothing but an ellipsoid. So x-intercept is going to be plus or minus a, which is plus or minus 1. Y-intercept is going to be plus or minus b, which is plus or minus 1/2. Z-intercept is going to be plus or minus c, which is 1/3, plus or minus 1 over 3. So all the variables have a square, have an exponent too, and they are all connected by plus sign, which is nothing but an ellipsoid. So every trace is going to be an ellipse. So if we consider x equal to k or y equal to k or z equal to k, all of them are going to end up with family of ellipses. So every trace in the planes parallel to the coordinate planes is an ellipse. So the surface is an ellipsoid. So the graph of the surface is shown as in figure 7. Now let's try the next one, which is number 23. So x square minus y square plus z square equal to 1. So we have a negative coefficient for y square. So if all the variables, all the terms are square terms, with one variable having a negative sign in front. So the surface is going to be a hyperboloid of one sheet, and also because the negative there is a negative coefficient for y, and the axis is going to be directed towards the y-axis. As the y variable, y term has a negative sign, the hyperboloid of one sheet is going to be directed towards the y-axis. So the axis of the hyperboloid of one sheet is going to be the y-axis. So the figure matches with number 2. The graph of the surface matches with number 2. Let's try number 25. So y equal to 2x square plus z square. Here we have variable y having exponent 1 variable x and z having powers of 2. So y cannot be negative here, because if y is negative, then sum of two squares will be negative, which is not possible. So there is no part of the graph on the negative side of the y-axis. There is no graph on the negative side of the y-axis. So everything is directed towards the positive y-axis. When y equal to k, we get 2x squared plus y squared equal to k. It gives a family of ellipse. So in the planes parallel to xz plane. As the exponent of the variable y is 1 and the other two variables have squares, this is going to be an elliptic paraboloid. The surface is called an elliptic paraboloid, and it is directed towards the axis of the paraboloid is going to be the y-axis, positive y-axis. So the figure for this one matches with 6. The graph of the surface matches with figure 6. The last one is number 27, which is x squared plus 2z squared equal to 1, which looks like pretty straightforward. So when because it has a missing variable y, so whenever there is a missing variable, it has to be a cylinder. And the other two variables have exponent 2 as well. So it's a missing variable y, and the other two variables are connected by a plus sign. So the graph, the surface is a cylinder directed towards the positive y-axis. Directed towards the y-axis. So the axis of the cylinder is going to be the y-axis. Or the rulings are parallel to the y-axis. Usually the rulings of the cylinder are parallel to the axis of the missing variable, so which is y here. So the rulings of the cylinder are parallel to the y-axis. So the graph of the surface in this case matches with figure 8. So in this problem, we identified some of the quadric surfaces, and we matched them with given figures in the problem. Hope this video is helpful.